Yes.
Okay. Okay, so hey everyone, my name is Kevin. I work for Prefect as an open source community engineer, meaning my job is mainly about like creating content like conferences, maybe blog posts, and then I also monitor the Slack channel, which we use as a support channel. So like I help people get started with Prefect or like use Prefect on their infrastructure. My colleague is also here today, Dylan. Who
Hello.
who is in DC. So I'm from Orlando, and Prefect was originally had an office in DC, and we've since gone remote, but we still consider DC to be our base. So with that, we'll get started with workflow orchestration. Why you need it in your for your work and what it can offer you. And then we'll show how, so we'll start by building a simple script that will track the price of a cryptocurrency. And then from there, we'll talk about how we can make that better with Prefect or with the workflow orchestration in general. And then we'll convert it to a Prefect flow. And then I'll show you a quick demo of that. So for our motivation today, we are interested in tracking Dogecoin prices. And I want to get an alert on Slack whenever there's a dip in price. So when I was making this talk, there was actually a massive crypto dip and everything, just the whole market like fell over 10%. So a lot of people, they look for opportunities like these, try to buy some coins when the market dips like this, and hopefully like make money out of it. So we're just gonna make this Dogecoin tracker in Python, and there's 4 main steps to it. So number 1, we're just gonna construct the URL of the API that we're hitting. Number 2, we'll actually put a request to that URL and to get some data back. And then after that, we'll just check if there's dips in the last window of time. And then if there's a dip, I will send myself a Slack notification. So this is what the code will look like for that. This is the function to format the URL. It's going to be a bit ugly. Just note that there is a URL here, and we are adding a start time and end time as parameters to that URL. So, and we are doing a 10-minute window. This API updates every minute, so we're going to get 10 prices listed, 1 for each minute. And then afterwards, we're just going to use this format URL function here and supply a coin. So here I'm interested in tracking Doge. And then we're going to get the data from there, put it in a pandas data frame, and return that data frame. And then once we have that pandas data frame, we're going to pass it to this function. I'm just getting the maximum price, the minimum price, and we're seeing like what the percent dip it is. And here my threshold is 10. So I'm saying if there's a more than 10% dip, then I want to be alerted. The last thing is posting to Slack. I won't implement this in Python because it's a lot easier to implement with Prefect, and I'll show that later. And then once I have this script and it actually works whenever I run it, I'm going to move on to deploying it, right? And the simplest way to deploy it would just be to like get maybe a box on AWS, like an EC2 instance, and just run the script in an infinite loop. And maybe every 5 minutes, I'm running this script. So this is my get data function, and then just check if there's a dip and post to Slack if there's a dip. And I could just leave this running infinitely. But of course, there's a lot of things that could go wrong with this, right? So what happens if an API request fails? The whole program will crash, right? What happens if I wanted to track another coin instead? Then I'd probably have to spin up another script and instead of Doge, pass in like Bitcoin or something like that. What happens if I just wanted quick off-schedule runs? Then I would need to probably spin this up again, take out the while loop and just run something. And then like what happens if something here fails, right? Can I get a notification about that failure? And all of these problems here, they are problems that we can solve, right? So if there is an API call that failed, we can probably do some try except, and we can probably just like loop through it a maximum number of retries. We could spin up scripts and like other copies of the script running, no problem. But each time we do one of these things, we're actually writing a lot more code that kind of pulls us away from what we set out to do in the first place, right? We're writing code to guard against failure, especially with notifications when it fails. And eventually what we'll find is that as we safeguard our code more and more for a production setting, we are in effect coding more against failure than what we set out to do in the first place. And that's what Prefect calls negative engineering. So as a company, Prefect's goal is to eliminate negative engineering. The Prefect founder, before starting the company, talked to a lot of data engineers, and as much as 80% of a data engineer's like work is about negative engineering and safeguarding against failure. So with that, our goal is to reduce negative engineering, right? And even like because so much of the work is about negative engineering, if you can reduce that negative engineering by 10-20%, then you can double developer productivity. So when we talk about negative engineering, we're talking about failure logic. What happens when that EC2 instance just goes down for a bit, like the internet connection maybe, so that it couldn't hit the API. We're talking about what happens if malformed data comes in, and then we want notifications and detailed logs if ever stuff doesn't work right. We want to be notified of it. We want failure messages. So these are all things that are safeguarding against failure and detract us from our original goal. So our goal is to allow data professionals to really focus on what they wanted to do in the first place, and that's what we call positive engineering. And with that, Prefect was born, right? So the Prefect originates from like our founder was a data scientist, and he made Prefect as a way to bridge data science and data engineering, right? So it's a Python-based workflow orchestration tool that's open source. Our Slack community, this is a bit outdated. We actually crossed 6,000 members. It's very active. We tell people to, like, if they just want to see what's up with Prefect, you're very welcome to join the Slack community. We take pride in really like answering as best as we can, like all the questions that come in, whether it be about Prefect or comparing Prefect against some other workflow orchestration tool like Airflow. Or like if in general you just want to talk about how you would deploy this, like how you would architect like this system, we could also provide feedback with that. And our GitHub repo has around 6,300 stars right now. Prefect was designed for the modern data stack, and we'll see this later, but it was specifically designed to handle the large quantities of data that we see today. So our founder was a very active Airflow maintainer, and Prefect kind of came from a list of things that he wished that he saw in Airflow that Airflow could have done better, but this list of changes wasn't, for one way or another, was not accepted, and that's when Prefect was born. So this is what Prefect is meant for, is to really handle the volume of data that we're seeing today. And because of that, we have it integrates natively with Dask. If you're not familiar with Dask, Dask is a distributed computing engine. So Prefect can use Dask in order to parallelize tasks and in general take advantage of that distributed compute power. There are two products attached to Prefect as a backend. I mean, these two products are the backend. So one is Prefect Cloud, where we host the UI and the database and everything. And then we have Prefect Server, which is open source, so anyone can just go and spin up Prefect server on their own infrastructure. Although we recommend that people use Prefect Cloud because Prefect Cloud gives everyone 10,000 free successful task runs every month. And that's more than enough to get started with and a lot easier to deploy than Prefect server. So with that, we're gonna convert our previous Dogecoin tracker into Prefect code. And here's how we do that. So the semantics of workflow orchestration and Prefect are comprised of flows and tasks, right? So tasks are more like the individual functions that make up a script, and flows are more like the full script. So tasks are just like one logical block, and the flow is the full set of those blocks. So to convert our Python function to a task, all we need to do is wrap it with a task decorator. And this now becomes a Prefect task. And because these two are already tasks, we can then use them in a flow. So here we have with flow and the name of the flow, and then we put our tasks underneath. And then now we can execute this with just flow.run. Oh, I'm sorry, there's so many chat messages. Okay.
Just us talking.
Yeah. Okay. Yeah. Thank you for posting the Prefect link. So yeah. So here there's some interesting things that are going on. So number one, notice here that we have this data equals the get data task. If you remember, this task returns a pandas data frame, and then we're passing the pandas data frame to this next task. So that's one of Prefect's main like advantages over other data workflow over other workflow orchestration tools. So we can pass data directly from task to other tasks in memory, whereas other tools like Airflow or like if you use like Flight, you would need to persist that somewhere, and then the downstream task would have to load it from somewhere. Whereas in Prefect, this is a first-class operation. The second thing to note is that once you pass in this data to the succeeding task, there's automatically a dependency that is set here where this function or this task will run after this task. And in other tools, you would need to set upstream, set downstream explicitly. Here, there's a more Pythonic interface. And then lastly, there's also local testing. So again, a lot of other services, you'd have to spin up the whole infrastructure or the whole like server just to get a test of one flow that you're running. Whereas in Prefect, this flow.run just runs the Python script as you would like locally, except that there's some additional logging attached to it. So with that, the next thing we're gonna do is we have an API call here if with that URL that we constructed. This API call may fail once in a while, so what we're gonna do is provide the maximum number of retries, and all we have to do is pass that to the decorator. Here we say max retries equals 3, and then we provide a retry delay where we set that this will retry every minute. Then a while ago, I mentioned I may be interested in tracking other coins. So here I am putting a parameter inside my flow. And this parameter, the default is Doge, but now I can supply a different value during runtime. Like I can say, I want to run the flow for Bitcoin instead or Ethereum instead. Now this coin will take that value and will run the entire flow with that parameter. You can also test locally by passing the coin as a parameter by passing this dictionary to flow.run. So now we can test this whole flow we can have an ad hoc run with a different value for that coin. And then the last thing I mentioned was that posting to Slack is a lot easier with Prefect, and I'll show why that is. But before we go into that, we are one of the things about Prefect is that it's very easy to extend. And I showed you earlier that how easy it was to make those Python snippets into tasks. So actually, we have a lot of community members that contribute tasks to our task library. And I would say 80% of our task library is community contributed. So a lot of people who aren't even like really familiar with Python, they still are able to use Prefect because of these built-in tasks. So for example, somebody can get like this Postgres task connected to an AWS task to upload to S3. Other people can simply use like Prefect to orchestrate like data jobs. So I can have a Databricks job that I just submit to Databricks to run, and then maybe the output goes somewhere else, and I get that output and upload it. So Prefect can handle. You can get really far just by using the built-in task, and it's also really easy as long as you can do it in Python. You can make a task out of it because these are all just using the API and Python code under the hood. So for me specifically, I'm going to use the Slack task, and I'll show how easy it is to configure that. So I am going to import the Slack task, and here the Slack task takes in two values. Number one is a message, and number two is the webhook secret. So the message, right, there's been a dip in Doge price. And then the second one is the webhook secret. So the webhook secret here is a secret value that is stored in the cloud. So the webhook URL is the URL for my specific channel that I'm going to be messaging. And I'm storing that as a secret on Prefect Cloud. And when this flow is being run, it's going to pull down that secret and supply it to this task. And then this post to Slack will now send the message to the channel that I want. So a while ago, we had this conditional logic, right? Where we had this like, if there's a dip, then I'll post to Slack. And I didn't set that up yet in Prefect. So the way to do this is we have a case task. And you can check, so this is basically the same as if this is true. So with case is dip is true, then we'll post to Slack. And with that, our base flow is pretty much done. All we have to do is register it now to Prefect Cloud. And it's just a simple matter of replacing flow.run with flow.register and the project name. So here we say flow.register tutorial, and we'll register it under the tutorial project. The last thing before we actually register it is that we need to give it a schedule. So schedules are comprised of clocks. So here I have an interval clock that I'm saying it's going to start now and run every 5 minutes. And then clocks take in parameters too. So here I'm going to say that this clock will take in the Dogecoin. And what you can do here is you can have multiple clocks for a given schedule because the schedule takes in a list of clocks. So I can also use the cron clock if I want to write my expressions in cron. And then second, I can also have other clocks devoted to other coins. Just checking if there are any questions. No? Okay.
Yeah,
Well,
so you can make, I guess you said you can make multiple flows within the same, I guess, Python script. Well, a clock will use like coin if you wanted.
sorry, could you repeat that?
Yeah, so you said you can make a different schedule for each like coin. So if I wanted to make one for Ethereum and Bitcoin, I'd make 2 other clocks, and then I can just call that flow 2 extra times.
So this the clock, when you do flow.run, you're calling just the Python script. But when you're actually scheduling it with Prefect on the cloud, then yes, you can supply like multiple clocks. You can have different clocks for different coins, and then Prefect will run all those scheduled jobs with those given parameters, right?
Gotcha.
And then aside from clocks, there are also 2 other mechanisms that you can use to adjust schedules. Number 1 is the filters. Number 2 is adjustments. So filters are like, don't run this on maybe, don't run this on off hours, right? Don't run this on certain days. Adjustments are then like, if you, for example, if it hits a weekend, you want to run it on the next business day, and then adjustments will bypass the filters. So with these three, there are a lot of semantics that you can use to make really complex schedules. And with that, let's recap what we covered. So first, we talk about flows and tasks, the semantics for workflow orchestration in Prefect. And then we went over some Prefect features, including parameters, retries. We talked about the task library and why how easy it is to get up and running with certain tasks, like querying from databases. As long as they're in our task library, it's very easy to get started with that. We talked about secrets and hosting secrets on Prefect Cloud. And then we showed that there are tasks that you can use to have conditional logic inside your flow. And then we registered it with a schedule. But we're actually, so all that earlier is more or less the basics of Prefect, not exhaustive, but more or less covered the basics of Prefect. And now we'll talk about one of the Prefect features that makes it stand out compared to other workflow orchestration systems, and that's mapping. So instead of having one coin here, I'm going to change this parameter to take in 3 coins instead.
I'll see if it's 8.
And for those 3 coins, I want to run the flow in a depth first manner, like all of those previous code that we had, like get data, detect dip, right? So all I need to do is use the map operator. And now that function is mapped, that function is mapped for each of those values that I had. So we get the default, our default, here we take in 3 coins. Now get data is applied to those 3 coins. Get detected is also applied to those 3 coins. And notice here that you can still pass this now list of data frames over here. And what Prefect will do is it will connect like the nth element of an upstream task to the nth element of the downstream task. So like Doge will run through get data and detect dip. BTC will run through get data and detect dip. And then it will execute in a depth first way. Now, because I have a list of these like true false, if there's a dip, I'm just gonna reduce that by getting the maximum. So the maximum of true false values will be true. So if there's a true value there, then I know I have a dip, and then everything below I don't have to change. And then in order to take advantage of the parallelism, all we need to do is change the executor it's running on. So by default, the default executor is a local executor which runs things in a sequential way, but we can take advantage of the Dask engine. So normally you have 4 cores in your machine. You can use the local Dask executor to take advantage of those 4 cores and run it in parallel execution. But we can actually use like spin up a cluster also to run everything with just by changing the executor. So here I'm going to use coiled. If you're not familiar with coiled is a so if you're familiar with Spark and Databricks, coiled would be the same for Dask. So coiled allows you to spin up manage Dask clusters. And then in our case, we're going to spin up a cluster, run the flow on it, run compute, and then spin it down when we're done. So all of this is coiled code. Here, I'm just importing coiled, and then I create a software environment. This is just their easy interface to create a Docker container from your dependencies. So I'm just saying I'm using Conda to install the following libraries. You can also use pip. The point is I'm just using their interface to create a Docker container. And then over here, a while ago, I had my executor be the local Dask executor. Now I'm going to make a Dask executor, and I have to configure it a bit. So I'm going to use the coiled cluster, which is a callable. So what's going to happen is this will make a cluster on the fly and supply these keyword arguments to it. This software environment is that Docker image that was defined over here. It just has my username prefix before it. And then we'll shut down the cluster when we're done. And then here's just a cluster name. So I'll show that. I'll give a tour of everything now. So we have so here is I'll show the Prefect dashboard. The Prefect dashboard shows my the flows that have run previously. I don't have any scheduled flows, but then scheduled flows would appear in yellow. Red are the ones that failed. Green are the ones that succeeded, and these are the ones that got canceled. So for me specifically, I already registered my flows in this project called OMLDS. I had another. This is another presentation I had. So we had this to the moon, which, if you recall, just takes advantage of a local Dask executor, and we have this to the moon with ARIMA. This the one that I just showed today, just now in the presentation, will be this to the moon, and we can run this. So what I'm gonna do is I'm gonna spin up. I spun up a Prefect agent. I'll spin this up again just to show. So here we use the CLI to spin up an agent. And one of the things to note about Prefect is that whenever you run a flow, you are running it on your own compute. So whether your own compute is like on your local machine or on an EC2 instance or like Kubernetes, you're the one managing your own infrastructure. And Prefect actually does not see any of your data, right? Or any of your code. Like, we only hold metadata, which makes us very compliant with security, like the finance and healthcare spaces. So specifically here, what I'm doing is I'm spinning up an agent, and this agent will be responsible for pinging Prefect Cloud every 10 seconds. Hey, is there a flow to run? And then if there's a flow to run, it'll pick it up and execute it. So if this if it detects a flow and executes it, this is all happening on my local machine. So with that, I have this to the moon flow, and I'm gonna do a quick run. And you're gonna see a run get created, which is this yellow one, and then it's gonna turn into a blue state when it's actually running. You'll see my agent picked it up, and now my agent has started the process that executes this flow. We can go inside, we can check the logs, see the task runs and their states. And if there's anything that happens, like if there's a failure, you can see it here or through the UI. And then what I am going to show you is that my last task, if you remember, was this Slack task. So I should get a Slack message over here, this 6:43, and it says there has been a dip in crypto price. And that's I ran, there's no real dip. I just ran it with a threshold equals 0 to force a message here. But here is the actual like the output of that flow that was just run. And with that, we're gonna take what we learned like one step further. So I'm gonna show this this Doge with Prefect was the code that we ran that I presented and walked you through. We're gonna make a couple changes here with this Doge with Prefect and artifacts. So one of the things Prefect can do is this artifacts tab, right? So whenever there's a flow run, maybe we're interested in persisting something here that we can revisit later attached to this flow run, right? So for my use case, what I'm gonna be doing is I'm gonna use a markdown artifact, and whenever the flow is run, we're gonna have like a markdown kind of report attached to it, right? So instead of, I'm gonna modify this detect dip function to actually fit a simple machine learning model, just a simple ARIMA, if you're familiar. And then we're gonna print the summary, and then we're gonna make a plot of like a forecast of like 5 minutes out what the price will be. And these are just plots, just some simple data frame operations and plots. And then over here is this S3 result. So the result interface in Prefect allows you, it's like an easier interface to work with places to store stuff, whether that be like S3 or Google Cloud Storage. So here I'm using the S3 result. I'm specifying a bucket and the location where to save the file. And then results are paired with serializers. So if you have a pandas like data frame that you're saving as a result, you can use the panda serializer, pickle that data frame, compress it a bit before you actually save it. And then when you retrieve it with the result dot read operation, then you would use that same serializer to unpickle it and then load it into memory. So here I'm just creating my result and writing out my result. The result here is the image. So I'm saving that image somewhere else so that it can be rendered. I'm saving that image in S3 so that it can be rendered in my markdown. And then from there, this is how I actually register a markdown. I'm just gonna add the coin name, the summary of my model, and the image location, which is formatted here. And those are all the changes I did. And so I registered this flow already. So this is the To the Moon with Arima. And we're gonna run, also note that I use the Dask executor here, the coiled cluster to spin up. And we're gonna see what that looks like. So I'm gonna, similar to before, I'm just gonna hit the quick run over here. And it's gonna spin up a new run for my agent to pick up. So here, what's happening is that I'm running a local agent, but that local agent will be responsible for hitting coiled and spinning up a coiled cluster. So if you go over here and you go to the logs, you're gonna see that the coiled cluster will be spun up. So here, creating a new Dask cluster with coiled cluster. So if I go to the coiled dashboard, I see that there's something pending. This is the new cluster that's being spun up for my code to run on. So it's pretty easy to set up. Coiled also gives a lot of free credits. And this is just a 4-core machine that I'm using, and it's pretty affordable. Over here in the software environment, you're gonna see this KVN code / Prefect. This is the Docker image that I built earlier from when I used this this Crate software environment that I showed earlier. And then, so this will take a bit to run. So now it's a good time if anyone has any questions.
I think mine might be better suited for the end.
Okay, so everything ran. I should have gotten a Slack alert again. So I got a Slack alert 6:49. But the cooler part that I'm gonna show is the artifacts. So I changed one of those tasks to to create an artifact, but because I mapped out that operation, I have that artifact across Doge, Bitcoin, and Ethereum, right? So I had 3 things in the artifact. Number 1 is the coin name. That's what you see at the top. Number 2 is the model results. It's gonna look really ugly just because you can't really control how it's printed. But if you really wanted to try, you could format things a lot nicer. The third thing is the plot. So here's the forecast that I had for that crypto price using the Arima model. And then I forecasted 5 minutes out. So I can do the same thing here with Doge. Looks like everything's going down, and Bitcoin. So now I have, like if I get a Slack alert, I can easily go to that flow and I can look for those artifacts and what images, and look at those images to see what actually triggered that notification, whether it be like a task, failed, or like whether in this case, like I want to catch a price dip, I can easily go here and check it by looking at the plots. And then the last thing to show is that I mentioned earlier that I was writing stuff into the S3 bucket, these images. So if you look at my flow run, this gainful hippo is the last one that was run. You're gonna find that there's a gainful hippo directory here. So I used the flow run information during runtime to create a directory. And then under here, I have the images for each of these. And with that's the pretty much the end of my presentation. If there are any questions, now open to any questions now. I'll stop sharing.
Cool, thanks for that. I guess my question is like, what sort of task would you say is best like run in Prefect? So obviously like there's some notion of like this cron-based task with parameters and like a good scheduler behind it. But what about long running tasks? Is that a case where maybe like if I'm daemonizing something or if I'm maybe listening to like a pub sub channel, is that probably better not in a tool like Prefect?
Yeah, so let's to answer that, it's easier to answer what we don't do first. And the number one is streaming, right? So a lot of people just like use us as a low latency poll, like you have an infinite loop that's checking like, oh, did something come into this S3 bucket, like a listener kind of system. No, Prefect is not like meant for that kind of thing. I would say Prefect really shines in number one, batch jobs, but beyond just batch jobs where you can actually pass data through, right? Because you can like actually pass stuff between tasks. But then there's also some interesting use cases I've seen. So for example, I saw a company that was using Prefect to orchestrate sub-prefect flows. So there were smaller flows that were being orchestrated by a bigger flow. And the reason they did that was because the smaller flows had different executors attached to them. So over here, I showed you how I spun up a Dask cluster. In the same vein, they were spinning up clusters also, but with different specs. So for example, if they were trying multiple machine learning models, they could use a model, they could have a cluster that's GPU enabled, but they don't need to leave that on for all the other guys. So they could just easily swap out the executors as they progress like through their flows. I've also seen use cases where people use not proprietary, but let's say really old software. Like, and this is like very common for like, let's say pharmaceuticals, right? Where they need software that was made in the 80s or 90s. They can easily include that in their Docker container. And I didn't show that today, but you can have like use that as in your Docker image, and then you can you can use Prefect to orchestrate like that Docker. I mean, you can use Prefect to orchestrate that Docker image. You can also store a flow in a Docker image, and upon runtime, Prefect will download that Docker container and run the flow. So you can also, like in the same light, like I've also seen people like we're Python based, but there's no reason you can't orchestrate other programming languages. So some people like you can orchestrate R jobs as well.
Thank you.
My question is with the agent. So I guess the agent's kind of really controlling when the flows are run. So I guess who watches the agent? Like what happened if the agent crashes? Like what kind of mechanism to manage that?
Yeah, so if we're talking about high availability, I have seen setups where you have multiple EC2 instances, right? And you can have multiple agents that are capable of picking up flows, such that if one goes down, another agent can come along and pick up that same flow, right? I've also seen, but then with I've also seen like high availability setups where there's only one agent on the interface. Here, I'll share my screen and maybe we'll look at how that agent shows. So if I go to my agent, you're gonna see this green one, and this is my local agent. And so you can use this like dashboard to like monitor the agents that are up and available to you. We I have seen people like have like this one agent actually corresponds to like multiple EC2 machines. So if one goes down, there's that resiliency. Yeah.
So I have a question around organization of tasks or flows, I should say.
Yeah.
Specifically, like, so this makes a lot of sense in this maybe more R&D kind of data engineering, data science environment. But like as things get promoted to, I guess, mission critical within an organization, like is like establishing a process or prioritization of jobs or tasks within or flows within your system. Is there some affordance for that, or is that something like that's more in the organization to figure out how they implement and prioritize things?
There is a way to isolate such that only certain hardware, only certain agents can pick up certain flows. And that's what we call, we have this mechanism called labels for that, right? So if I say that this agent is for the prod flows, then it can only pick up flows with that same label, like prod label, right? So in that sense, there's some isolation there. If you're talking about like these, well, flows, if an agent picks up multiple flows, it will run all those flows like concurrently. But if you're saying that you want flow 1 to finish and then flow 2 to start, there are ways around it. What you would do is you would just wrap those into a larger prefect flow to create like that sequential dependency, and then you would, like, even if they're not inherently dependent, you would just make that sequential dependency so nothing like crashes, and then you would run that larger flow. So there are ways, pretty much ways to do whatever you're looking for, I would say.
But organizationally, then would the idea be like, would the idea be like, well, there's one giant Git monorepo of everyone's like prefect flows, and then everything like is interlinked there, or
I see.
Yeah.
So okay, so I guess the question here is, hey, what if anyone just comes in and just starts their flows left and right, and like we crash the system, right? So we actually rolled out a new feature, which is a role, like our back, like role-based access controls. So now you can control, like, for example, we have a dev environment and a prod environment. You can control who actually has access to that prod environment, and people without access to that prod environment will only be able to register flows in the dev environment, right? And then again, like with labels also, you can preserve that, hey, these are production labels, and like this stuff being promoted here with this label only like should be production ready, right?
Thank you.
Sure. Are there any, like, I don't know, do people like what do you guys use for your, like, in your work right now? Like, do you use like Airflow or Dagster, or I don't know, Flight, Argo?
Yeah, I was about to ask. So we use Airflow, and I'm just wondering if we're already using Airflow and it works pretty well. What's like the biggest reason to either use both or to switch over fully?
Yeah. So the thing with Airflow is that I mean, some of these have been addressed in Airflow 2.0, but there are still like Airflow as a system was designed, you know, like way earlier, like maybe 2014, 15.
Yeah.
Prefect is around 3 years old now. So because of the more modern stack, there are a couple of things that like Prefect does in terms of handling data better. But like, even from a user perspective, I've heard a lot of people not be happy with Airflow because of how bulky it is to set things up and just experiment. So the cycle of development is certainly like a pain point. Number two, like, from my understanding, ad hoc runs is also pretty difficult because everything is tied to a schedule. And then passing data between tasks, you would need to persist in one place and load it downstream. I think they actually have something in 2.0 that addresses this. And then what I showed today is that we didn't have to change the code, but we were able to dynamically map, right, and alter that DAG under the hood, like during runtime, based on the number of elements that it's on the list to map over, right? So Prefect has really strong semantics for these types of operations where you're mapping across a cluster or across your hardware. We have a lot of people migrating from Airflow, and they just like, you know, gradually do that process. From what I've never seen this yet, but I know also that you can also orchestrate Prefect, I mean Airflow jobs with Prefect. Dylan, if you're around, feel free to chime in, and Zach Kingsley, but if you don't want to chime in, that's fine.
Well, we've used Metaflow, and I think one of the things I've seen for Prefect that Metaflow really doesn't have, like, I like the artifact storage. So kind of in the UI, Metaflow has a similar flow structure, but doesn't really have some of the, I guess, user experience tools outside of that. So it's good for running locally and or testing stuff, but if you want to scale it out or wanting other like non-technical users to interact, I think like that artifacts and the way for other people to see was a much better interface, and Metaflow doesn't have any. So yeah.
Yeah, I see Dylan unmuted. Do you want to say something, Dylan? Oh no, maybe not. I don't know. Feel free to chime in. So with like, because I handle the community side of things, I see a lot of people, and you mentioned Metaflow. I've seen a lot of people use Prefect plus Metaflow or Prefect plus ML.
MLflow?
What's the MLflow? Yeah, MLflow. So I was a data scientist for 4 years before Prefect, and MLflow has really strong artifact registry, has very strong experiment tracking, right? So for if you have tools that are strong in those things, you can use Prefect plus those tools. So you can use the artifact registry of MLflow. You can use the experiment tracking side of it, and then you can orchestrate with Prefect. And this is because Prefect is such a like general purpose tool. It's not, I won't say it's, there are other tools that are like specifically designed for data science, and Prefect is not one. Prefect is a general purpose tool, but because of that flexibility, you can mix and match with other workflow orchestration tools as much or as little as you want, right? You can really like, yes, like MLflow will have a more robust artifact tracking system. So you can use it with Prefect. For example, logging also, like Prefect has logging, but there are other tools that have stronger logging like Datadog, right? We're not going to replace them, right? So you can use those two together. And more recently, there's been this hot topic around data lineage, right? Where you track, hey, the data set has changed in these multiple, like with these transformations, and you want to keep track of that metadata as it progressed through. We don't keep track of data, so we can't do that inherently. But you can use some other service with Prefect in order to do that. We won't even see that metadata.
Very cool. Thank you.